Hello ladies and gentlemen, my name is Nick. Welcome to Angelonic Video Tutorials. Today we will talk a little bit about something very special, and just some people discuss about something like that, in general, people who do research, scientists or research engineers, but also other developers, software developers, must know about all this. Why? Because till now probably a lot of developers know about some programming languages like Java or PHP, or in our case, because I discussed about programming languages from Microsoft, so in this case we discussed in the past about VB.NET, Visual Basic.NET, okay, C# as a programming language, or F#. Now we can discuss about another programming language who can be implemented and can be used for quantum development, and it's about Q#. Q# is a programming language dedicated for quantum computing, quantum programming. But before of everything, we need to know what's going on with quantum, and what is quantum, why is quantum, what is quantum computing, for developers who really know to develop software. This is not for entry levels in software development. This is for developers who really know to develop some software, and want to know to develop a software, to develop algorithms for quantum. Let's start to understand a little bit about quantum computing, quantum programming, or quantum development, and what's going on in all this. Everybody knows about cloud, everybody knows about cloud, and cloud computing, cloud development, and cloud programming, and so on. Good. Now it's quantum. In the past, some mathematicians described in mathematical part a quantum, a qubit. What's that? Wow! Let's start to see what's going on. I took from Wikipedia, and thank you for that, for them. What is quantum computing? Quantum computing, they said, is something like this. It's an exploration of collective properties of quantum states, such as superposition and other type of things like to perform computations and so on. Basically, for people who don't understand what was there till now, probably exists, this kind of quantum, basically, you as a software developer, as a normal software developer, you develop software using bits. Bit 1 0 1 0 1 1 0 1 0 1 0 1 0 1 0, and so on. 1 or 0, 1 or 0, 1 or 1 or 0 or 1 or 1 or 0. Whoo! This is the language of a computer. Basically, computer don't know text, don't know images. The basic language of a computer, the basic data processing for a computer is binary. Okay? 1 0 1 0. Quantum is something like, that's why it's qubit. It's some bits put it in multiple stages in the same time. 1 and 1, doing the multiple stages, multiple status in the same time. That's why it, to say it like this, it a lot of resources. And for this exist quantum computers. Quantum computer is hardware. It's a real hardware part who is created, and do that part create qubits for you. Existing cloud, you can use Azure quantum computing, Azure quantum computer, and so on. Or in other clouds, or from other systems where exist physically as a hardware a quantum computer. Okay, Good. We understand what is a quantum. We understand what do the same in multiple stages in the same time. For example, you need a lot of memory, you know, for speed. A lot to do just a simple thing between two stages or two qubits. You know, very expensive to say like that for someone who tests that. We can test it home in simulations, and we can create basically something like algorithms to do something with that qubits. We have qubits, okay, we have 1, 2 qubits or multiple qubits, depends by the power processing in hardware, okay. We have these qubits and we need to do something with them. We start to do something with them, put them to think, put between them to do something like have a logical part, an algorithm. What is an algorithm? An algorithm is something who have a stop, have some properties like you know, properties of algorithm. People can check him back for other video tutorials about that if you don't know about that. It's in software development. It's not about quantum. It's with algorithms. Basically, everybody to understand what is an algorithm, and it's not necessary to be a software developer. It's something like that. I want to create a toy. Perfect. What I need to have? Primary things, you know, so primary data, input data, to take something, put into a machine, and that machine will compose, put everything into one process, not randomly, you know, at the end of the machine to have that toy. That's the result. Boom. Okay, correct, beautiful. What we need now, we need to create an algorithm. I mean, to have brain, to do something, to have that stages, have that process, to have start, having some qubits, and at the end having a result for the qubits. Wow, perfect. For this we need what we need. We need quantum programming. Quantum programming is the process of assembling sequences of instructions called quantum programs that are capable of running in a quantum computer. So basically, some instructions, some functions, put it together, instructions created by us, put it by us, you know, to have something, okay. Basically, mathematicians with research engineers in general start to create some algorithms, some methods to compose something with that qubits. Why it's a qubit and not bit? Because having multiple stages of that in the same time, will be very fast. I mean, and a lot of resources in composing, in processing after that. So basically will be wow. Okay, good. If people want to know more about quantum computing and quantum programming, you have entire internet for that. You can check what's going on with this. I'm focused today only for part to apply quantum development using Q#. And by the way, using something like an IDE like is used also for C# or for F# or for VB.NET, meaning here Visual Studio. If in the past, you know, everybody knows, I will do websites, perfect. I will do WPF applications, perfect. I will do WinForms applications, desktop applications, perfect. I will do mobile applications with Xamarin, perfect. Now you can do also quantum. If in the past we discovered something about machine learning, doing machine learning also with Visual Studio and in C#, in this case we have Q# is very similar with C# as a composing part, structures and what's going on there, keywords and what's going there. So we can use Visual Studio and this programming language. Q# is from quantum, okay. Q# and Visual Studio to create a software, to create an algorithm for a qubit or multiple qubits. In this case, look, a qubit. A qubit is something like, in quantum computing, a qubit or quantum bit is the basic unit of quantum information. Like bit, the basic unit in PC, in processing for computing. Okay, the quantum version of a classic binary bit physically realized with a two-state device. Wow, good. In this case, let's start to see what's going on. We have here Visual Studio, and if you can see here, we can create also Q# applications, Honeywell or other types. That's for Azure, for cloud. Can you see? You can create an application using Azure Quantum in cloud. Azure Quantum, basically, it's a quantum computer physically there, you know, in cloud, and you can use it, you can access it, and you can use it to have power of processing, enough power of processing to do complex algorithms based on qubits. Okay, nobody home have that. Believe me, nobody home have that. So in this situation, we will go to use something like application, a simple application of Q#, basically Q# program language. A simple application. We will do something like a local application simulated. For that to see, you can start to create software. You can start basically to create algorithms for this type of computing. You know. So exists also what I want to show you today. Exists also development for what? For quantum also. Okay. So in this case, let's put something like let's say quantum training. Okay, location is the same, and quantum training solution. Perfect. Till now everything is perfect. It's the same like any kind of application, any kind of template, to say like that, to create an application using scaffolding from Visual Studio. Create. And now we will have something. It's very fast actually, because I don't want to create too much. I can't. I don't have power in my computer. Even if my computer have 16 giga of memory, it's not enough to process more than one, maximum 2 qubits. So there you will see, will be, if you want to go more with one or more with another one, will extrapolate. Basically, you need to put not 16, you need to put 116 giga, go to a terabyte. I mean, a lot of resources, and nobody have it home. Okay, but we can use this, and we can have a simple algorithm, a message, hello quantum world, you know, having something like namespace, the same like in C#, quantum training, open, basically it's using from C# of Microsoft Quantum Canon. It's the type, take it from dependencies. Basically here we have the structure, you know, the structure have dependencies, have okay, we have some analysis here, we have some frameworks here like .NET Core. By the way, it's not in .NET Framework, it's .NET Core. Okay, so in .NET Core, it's a .NET Core app application, and here we have the packages basically for what? For this type of application. We have Microsoft Quantum C# generation, entry point, because we have an entry point, Q# core, you know, this is for programming language, and runtime core is basically to do that, to process that, everything. A simulator or simulators, because we will simulate everything locally. It's not necessary to go. We can connect. You saw, if you really want to do something more complex than what I have here, you need to connect in cloud with a real quantum computer. So we have simulators, and we have also some standards for this part. Okay, good. So we have all this. Perfect. It's brilliant. What we can have first, to have all this, you need to go where exactly? Extensions. Manage extensions before have, because if you don't apply an extension named Quantum Development Kit, you can't create something like that. You can't. You don't have it. So in this case, you need to go online, not install online, and you can choose Quantum. Okay, and automatically Microsoft Quantum Development Kit will appear. You need to install it. This to add on your Visual Studio, basically this. Okay, without this you can't do nothing. After you install it, reboot the IDE, I mean Integrated Development Environment, meaning here Visual Studio, and after that you can do new project, and in that new project exactly that steps, you saw the steps, you know, to create a quantum algorithm. This is a very simple one. Basically, in all this is the part for create something for quantum computers. Okay, perfect. So if someone thinks it's something with a very sophisticated interface, in general in quantum computing you don't have a very interesting interface. You don't have, because it's just pure mathematics there. Okay, you use a lot of mathematics, or in case of you don't use that mathematics, a mathematician do that part, and you need to apply in these stages, you know, what mathematician did in presentations and logical part, you know. So basically you need to apply to check if everything is correct what was there. In our case we have packages. I waited a little bit to update the packages automatically, you know, taking the packages. You saw was here a little bit of warning. Now it's everything is okay. So if you are not sure everything is okay, you can go on packages and can manage NuGet package, and you can see if some updates exist. Okay, so this is the part. It's very simple one, I told you, because it's simulated in qubits and takes a lot of resources. Let's start to see what's going on, and we will see a simple console. Okay, and in the console has hello quantum world. If you want to do more than this, you can do a lot. You can do something like doing a body, and that mutable, and in that using a register, like a qubit is registered qubit, and go you will see then like a class in back, but it's from Microsoft Quantum, and taking from there basically you can do how many qubits you put it there, you know, 1, 2, 3 bits, you know. So after that you need to take the every qubit and do something with that register, and after that to teleport the bits. You can do a lot of big beautiful algorithms if you want with this. In my case I just have enough power in my computer to do this, okay, for you. Basically you can start, and I really hope in the next year or very short period to see people who create quantum algorithms, to see HR agents who will do something like, yes, look guys, this is good, let's create, let's hire some quantum development or quantum programming or quantum developers. Ladies and gentlemen, thank you for watching to this video tutorial. My name is Nick. Till next time. See you. Bye.